really appreciate this being setting up and all of y'all coming up. Well, I guess introductions. I left Rod off when we handed in this title earlier. Rod's done an awful lot of the reproductive stuff. Kerry Maxwell, in the middle of the room there, has done a lot of this aging work. So those are the two people who have done most of the work on this. Certainly Lynn Cox, one of our predecessors, who many of you know is off teaching school right now, was a big player in this. And of course, John has been guiding us through this for a very long time. Should have emphasized very long, I'm sorry.
Very, very long.
Breaking this down, real simple question. Why are there big lobsters some places and not others? You start thinking, oh, they grew more, they're older. You've got the basic answers in this. But we've actually come up with a couple of different answers from that. And a lot of it is sort of based on what I'm about to start showing you here. We get into, so I'll start off with some lobster abundance information, size and age, growth rates, and then we'll convert that sort of into egg production. How does this size and age stuff actually end up influencing eggs? I think y'all have seen this a lot, starting off in the 50s, sort of lower levels. In the 70s, there was some increased effort for just competition between fishermen. Also, the Hemian fishery being closed brought those traps in. A fairly long period of stable landings, and then those decreased landings here. Put some markers on this. Basically, at about here, we were already at those 500,000 traps in the fishery. And there was some increase near through here, but basically landings were pretty level. Trap reduction started about here, landing stayed high, and then we had this stair-step drop. There was 1 year in here, which might have been the last bad year of the good times, or a good time in the recent bad years, but really, over the course of 2 seasons, landings hugely dropped. So this is sort of a history of lobster abundance. I tend to think our catch is a good measure of abundance through time, because we've basically been catching most of the lobsters out there. There's not a lot of evidence that a large number of lobsters are remaining in the environment. Now we've done some different study work. I'm going to call this area the Keys fishery. Basically from the upper Keys through Marathon. Several fishermen have brought us animals over the years through this area. I'm going to refer to the Tortugas open fishing area as this area here, where we've been out with fishermen, collected samples in 2002 to age lobsters. And the circle around that little area, I think you've seen this before in one of Rod's presentations, the Western Samples Ecological Reserve, I'll start showing that as WSER, the abbreviation for it. So these are the 3 areas where we know the most about lobster age. Some of Rod's work earlier, he went through the literature and found a lot of information about how many lobsters are in an area. So I've showed you that graph of commercial landings, how many lobsters were in the fishery every year, but now let's break it down into hectare. A hectare is about 2 football fields. So how many lobsters in these different areas live in about 2 football fields? Dry Tortugas National Park, R means protected. That Western Sambos, protected again. Blue Key, which is actually a fairly small protected area when you get right down to it. We now know lobsters are moving up to half a mile a night and stuff, so a lobster can walk through this area in one night relatively easily. Those spas, the special protection areas, these areas are even smaller. They were never meant to protect lobsters. They're just around the core areas. There's certainly lobsters in them, but they're likely leaving on a regular basis. And our 2 open fishing areas, the Tortugas Banks, which is very similar to the area I showed on that first map, and the Keys fishery. Excluding the Western Sambos Ecological Reserve, which has very high densities, and this was after that area was closed in 1996? 1997 it was created. And the Tortugas Bank, which has very low numbers. Most of these numbers, 72, 69, 87, 66, those are all basically the same number. So in much of the areas around here, there's the same number of lobsters in many of these areas as far as density goes. Protection in the Western Ecological Reserve allowed those numbers to basically double. And Tortugas Bank, there is some fishing activity out there. There's probably low density there beforehand. Again, we can't say what should be there and what shouldn't, because really in all of our experience, it's always been an open fishing area. that Oak Keys open fishing area, so from the Upper Keys through Marathon, this graph is sort of the number of lobsters in our sample, and here's their size. So that legal size in millimeters here is that 76, about right here. So as you might expect from traps, most of the animals are undersized. The white bars are the males, the dark bars are the females. So in 2001, and this really hasn't changed much over time, so 2001 is really nice and representative. I'm using that year because I'm about to show you some age data, and that's when we did the work. Most lobsters were below the legal size limit. Equal numbers of males and females below 2.5 inches. These aren't sexually mature animals. Males and females are really behaving just the same. You get into the 65 to 85 when we start reaching maturity, and there are more females. So once we reach maturity, more females are showing up. Probably what's going on is the females are growing a little bit less. So this might be just a factor of growth. Males over 85 millimeters, so this is that typical 1 pound lobster you might see, males become more predominant. So part of this is likely because, again, that growth rate. Males are growing faster. They're simply a larger size as we measure the length of the shell here. Over 100 millimeters, all lobsters are rare. So that's that 4-inch shell, 2 pound lobsters. We simply don't see many of those in the fishery. What age are those? So this number on the bottom, the huge word here, neurolipophosphamate. This is the waste product that builds up in cells. They can't get rid of it. If you measure the amount of that waste, in some studies, it's been a pretty good proxy for age. If that number is, there's a formula behind it, but basically the difference between a year 1 and a year 2 lobster is about 0.3. So that's how we separate the ages of these. So this whole big curve of lobsters, these are our year 1 lobsters, basically animals between 1-year-old and 2 years old. About 18 months here. So 84% of the lobsters in our population in the fishery are what we call that year 1. 16%, those near 30 months, are year 2. There's a handful of lobsters we've seen that are older, but very few lobsters. So there's a very high total mortality. The combination of natural mortality, fishing mortality, anything else out there that can kill a lobster has taken a huge toll on these lobsters.
And that's all lobsters, legal and sublegal and everything?
This is legal lobsters.
Just legal?
Yeah. So that was an easier thing to deal with. We can't really measure the amount of that chemical in a very small lobster. It doesn't show up till that lobster is about a 1-inch shell length. So the very small lobsters, the data was very hit or miss. But once the animals get in that legal size range, we're still getting some with very small amounts. So yeah, I'm not saying that, so any one lobster in this, we might not know the age. But if you measure enough of them, the distribution is probably true. Yeah, this wasn't a newborn lobster that was 3/4 of a pound. It's just in this particular lobster, maybe something was wrong with the eye, caused the chemical not to deposit. But yeah, so I can't pick up a lobster and say how old for sure this one is. But if I pick up 100 lobsters, I'm pretty sure what the average age of one. And that's what this shows us. So, lobsters are really young in the Florida Keys. This is almost an annual crop. Lobsters, we think, are supposed to be living to be about 20 years old. Going into that Tortugas open fishery way to the west, we collected these animals in 2002. Very few animals were below the size limit. More males, relatively more females than males, all the way up to 130. So most of this is black. So the vast majority of the animals we were seeing were females. Almost all males over 130 millimeters. Males grow quicker again. So the shell grows a little bit disproportionately to the rest of the body. So this isn't overly surprising. But that's our typical size distribution we've been seeing in that Tortugas open fishing area. Now the ages of those. Here's those age 1 lobsters again. Made up 67% of the population. In the open fishery, remember, it was about 84. Those age 2 lobsters are about 22%. And 11% of the lobsters are old. This looks strikingly different, that we've got all these older lobsters, but really, only about 17% of the lobsters in the Tortugas are older. So that was a pretty big shock to us. We've got all these big lobsters out there, but really, they're about the same age. The vast majority of these lobsters, in this case 89%, were the same age as the lobsters in the fishery. only a very small handful of animals, 11%, were older. And when you add up the differences between these from year one, 17% of the lobsters were over year one as opposed to in the fishery. So we think of the Tortugas as being a very different place. It's not really. There's a pretty minor change in age that really sort of shows those big differences in size structure. So why are Tortugas lobsters bigger? There's more one-year-old lobsters in the Keys, so definitely there are more younger lobsters in the Keys than the Tortugas. But what's really going on is it's the slower growth rate of lobsters in the Florida Keys. So here's some graphs. Let's start off with this dashed line right here in the middle. I know a lot about these lobsters because I caught them as that little clear prairie line, and I kept them for up to 7 years. Now, I hand fed them. They got $2 worth of food every day. They were very happy lobsters. So, boy, do I know this curve is absolutely correct, but it's in a laboratory. How does it match up to things in the field? These dark squares are the Florida Keys males. I've got another graph for females, but I didn't want to picture too many graphs, and this one basically tells the story. Here is that huge cluster of one-year-old animals. Here's some other animals. So basically, the biggest group is here, but then there's this group here too that are 3 years old. So 65 millimeter up to 75 millimeter. Now there are some 3-year-olds that are in that 100 millimeter range. And so that's that growth curve. It slows down as they get a little bit older. Here's our dry Tortugas males. Those 1-year-olds are already averaging over legal size. Our 2-year-old animals are here. So you can see these two groups are almost totally separated. The growth rate of these guys in 1 year gets them to about the size you want to put as a bait in your trap, where the Tortugas animals are already legal sized. And there's that curve here. Put some size on these. So here's that age 2. If you bring over the Keys animals where it crosses the line, that 2-year-old animal might be 100 millimeters. In the Tortugas, that animal might already be this would be a 4-inch shell, and this would be about a 5-inch shell length, to sort of give you an idea of what to do. So huge difference. Now, I'm not actually measuring age. We're measuring that chemical that's building up. We think it's a pretty good measure of age, but this could be shifted either way, a few months or something like that. But the big difference is here that I think is probably relevant is that growth difference. So, slower growth in Keys, possibly very high growth in the dry Tortugas. Moving into the western Sambos. So that area was designated in, I believe it had protection in the season starting in 1977. This is some of Lynn Cox's works, again, when she was managing the program back then that Carrie's managing now, when we measure the abundance of lobsters in the area. So going through the graphs, this data is 1997, 98, 99, 2000, 2001. So these animals in the first year of protection, the average really doesn't change. This is a fairly small area in the middle of the fishery. What's going on around it totally affects what's going on. It's, for example, if you had a dinner plate next to a buffet. Most of the chickens on the buffet, and it's going to get to your plate, they're all coming from the fishery on their own. But these larger lobsters were increasing in number. So over the 5 years that we've got the data here, more and more larger lobsters were building up in the sanctuary. The average was still driven by outside, but inside we are retaining a small number of lobsters, and those lobsters were growing up very nicely. Breaking down that same data into the size of the males and the size of the females, here's that shell length again. Legal size is 76 millimeters. So in the western Sambos on the Atlantic side, relatively few small animals. The bulk of the animals are really from that 3 inches up to 4 inches. But we've also got some larger males and larger females. Now in this case, the females are only making up to the 4-inch shell. The males, 4 inches and 5 inches. So we're getting some very large males. So we're not seeing the bigger females in this western Sambos protected area, but we were seeing much larger males. There were definitely some, but not nearly as many as in the males. Looking at the age again. Now, here's our females and here's our males. a nice big distribution. So here's the 1 and 2 year olds. We couldn't really separate groups as nicely as we could in the fishery and the dry tortugas. So how we chose to look at this was who was over 2 years old and who was under 2 years old. If you remember, in the fishery, 84% of our animals were 1 year olds. The rest of them were 2 year olds. So we really only had 1 and 2 year old animals in the fishery. After just 6 years of protection, approximately half the animals, 45% for the females, 54% of the males, were already over that. So even though the size differences weren't that big for the females, we just changed a huge bulk of the population, and now we have this as a multi-year fishery, or multi-year population. So almost half the lobsters were over age 2, so we had a huge shift in the age of the lobsters. Interestingly, we've had 6 years of protection. That's about how old these oldest lobsters were. So as many years of protection we had the lobsters that were protected as long as the sanctuary had been there. That's probably more of a correlation than a direct effect, but it was very nice that those two numbers lined up. Here's some of the raw data. What we went out there and did was caught a bunch of animals from that were in this size, a bunch from this size, and we worked very hard to find the largest animal. I wish Ernie Patone was here. He actually took us to his secret spot where he has very large lobsters. Basically, those don't occur anywhere else in the Keys fishery. He took us there, and that's how these fisheries animals in the green here were able to get so many lobsters from this. So this isn't a random sample. We went out very hard looking for the biggest animals, thinking that they would be the oldest in the fishery. So here's our graph. 1 year old, some of those big lobsters were still very young. In the western sambos, here's those older animals. The triangles are the females, the circles are the males. So some of those oldest animals happen to be the females. The females seem to be moving less than the males in the western sambos. On average, our western sambos animals were almost 2/3 of a year older than the females. So the average lobster in the sambos was over 2 years old. In the fished area, as you already know, it was less than 1 year old. There's substantial overlap in the western sambos. Fishery animals, most of the population, they're all recruited every year. They're basically the same lobsters, but a handful of lobsters are being retained, and those are some of the oldest ones. Looking at that same data, just in a little bit different way, here's the little lobsters from right around 3 inches, from 2 3/4 up to about 2 1/4. 3 1/4. Again, same colors here. The greenish is the fishery, triangles females, circles males. These are all the same age animals. So those 1 year old animals are all the same size. When we get into the next size group, the fishery animals are still the same age, still those 1 year olds. In the western sambos, the males are a little bit older, but look at the females already. Those females that are legal size, right around a pound lobsters, are much older now, up to 3 years old. So our females are aging, but they're not really growing. What they're doing is putting the energy into reproduction. These are the girls who are making eggs. That variance, why this line is so big compared to some of the other ones, is because only some of the animals are older. Most of them are still down here behaving like the fishery animals. They're the same group. So the reason this variance around the females is so big is because we have a huge range of the age. Some of them are still 1 year olds, just like in the fishery, but some of them are up to 6 years old. So the biggest thing going on in the fishery is in the protected area, the Western Sambos Ecological Reserve, is that many of the animals are the same as in the fishery, behaving just the same, but some are being retained. They're much older, but they're the same size. The energy is going into reproduction, not into growth. So, I've just hinted about what's going on with those animals. In the Tortugas fishing areas, some of the lobsters are big simply because they grew fast. In the Western Sambos, some of the lobsters are big because they're older. So, females in the Western Sambos, some are much older. Why is it important to have these older lobsters? And the answer is staring us right there, the amount of egg production they're having. spawning frequency. If I went out at any one time and looked at lobsters, how likely are they to have eggs? As we all know, small lobsters, those around under 2.5 inches, really none reproduce. Those coming up on 2.5 inches, about the same proportion in the protected area of the western sandbows had eggs as in the fishery. Now when I get into those just undersized and legal sized animals, again, about the same ratio. But when I get into these slightly larger animals, in the western sandbows, more reproduction, and certainly these very large animals in the western sandbows, all of these large animals were always reproducing. So these larger animals, which we now know are much older in the western sandbows, are reproducing all the time, where in the fishery, the reproduction was less likely. They're the appropriate size, but in the fishery, they're not the right age. They're basically big juveniles, and many of them are not reproducing. How many eggs does a lobster have? So here's that shell length again. This dotted line is close to legal size. This is actually the average size of lobsters in the Florida Keys fishery. So these lighter gray, we went out and we caught lobsters. They were from about 60 millimeters up to about 90s. That's as you're used to that average size. 2.5 up to about 3.5 millimeters, carapace length, shell length, or I'm sorry, inches. And here's the Tortugas animals. Exact same curve, but the Tortugas animals are bigger. So the relationship, it's not a straight line, so it's not that when a lobster gets bigger, it proportionally has more. It's slightly exponential, or a power curve. So the bigger a lobster is, it's not exponential, it's not doubling or tripling, but it is increasing somewhat more slightly. The dotted line here and the dashed lines are the mean clutch size. So in the Florida Keys, it was a 79 millimeter or so lobster was our average, and that animal this would be 500,000 eggs, because this is millions, is producing about 300,000 eggs. Our Tortugas, or any bigger lobster, is out there producing about 800,000 eggs. So in Tortugas Park, the closed area that's been closed since the 70s, each female, every time she has a clutch of eggs, she's producing 2.6 times more eggs. Lots and lots more eggs in every single clutch they're producing. And there's very little overlap in the size of reproduction in the Keys. Some really neat theoretical work Rod did is, here's our shell length again. Legal size is right here. And this graph here is the number of eggs per gram. So a 1 pound lobster is 450-ish grams, would be right about here. That lobster is not very efficient. So when this curve peaks out, that is the most efficient a lobster can be at making eggs. If it's making eggs smaller than that, it's sort of wasting a lot of its energy. It's not being very good for the amount of body it has for the egg production. As they get bigger, that drops off too. So this range between that 80, which is just above legal size, up to that 2.5 pound lobster at 4 to 4.5 inches is the sweet spot of reproduction. Female lobsters, body mass, efficiency is the best at making eggs at that size. It's greatly reduced at smaller size. Right now, the average size of reproduction of Florida Keys lobsters is down there in the mid-70s, or size at first reproduction. So we can see that number's right here. In our fishery right now, lobsters aren't reproducing when they should be. Something has gone on in the Florida Keys that is making these lobsters reproduce much less efficiently than they do in other areas. And here's those other, so here's our areas in the fishery. Mean size of reproduction is always below this sweet spot. Again, up by those things. So here's that sweet spot of reproduction between just over 3 inches and just shy of 2.5. Our Tortugas lobsters, this graph right here, they're in the sweet spot. So that area that's been protected for over 30 years now in the park, those lobsters physiologically, as this model tells us, are doing exactly what they're supposed to be doing. Upper Keys, Middle Keys, Lower Keys, even west of Key West, all of this reproduction is more in this range. The female lobsters simply aren't being that efficient. Little tough to get through this one, but we'll go through it slowly. This is the dry Tortugas park again. Here's the Florida Keys open fishing area. So on this, going deeper into the page, is the size of the lobsters. Here's the calendar, April through October, so the seasons. And here is the percent of the population that's making eggs. So in the dry Tortugas, in April, this bar is up at 100%. So large lobsters, in April, all of them are reproducing. Let's look at that same place in the Florida Keys. Large lobsters, April, none are reproducing. Well, there really aren't any lobsters that large. Back to the dry Tortugas, those large animals finish reproducing earlier in the year. So large lobsters in the dry Tortugas, all of them are reproducing very quickly in the spring, and they finish very early. In the fishery, some of these female lobsters are reproducing well out into September, October. You can see it's flattened out here, but in the fishery, they're still producing eggs. So in the fishery, the breeding season, when females have eggs, is extended. It's a much longer period of time. In the Tortugas, where we know our females are being the most efficient, we think doing what they're supposed to be doing, the egg production season ends. It's much more truncated. So on our old multi-year population, these animals are reproducing quickly, getting it over with, and getting on with the rest of their life. In the fishery, we've got all these animals that are essentially reproducing in the later half of the summer or the later half of the fall. I sort of think of this in terms of, what if birds didn't nest in the spring and they started nesting in the summer and the fall? Would those young still be able to reproduce out there? We have no idea what it takes a larval lobster to survive and spend the rest of its life. But in our most natural population, that this is truncated to a very short period in the spring and summer, and it's extended here, leads us to think that something else, that the timing of reproduction in Florida fishery probably isn't exactly what it should be. Moving on back to the Western Sambos Ecological Reserve. A little bit closer to home, we can do some, I'm sorry, this isn't in the reserve, this is in the rest of the fishery. We went out to the reef in April and caught lobsters that had eggs. We're calling those reef ovigerous. Ovigerous means they're carrying the eggs. Ovigerous later means we went out in April, they didn't have the eggs, and then we went to the bay and the bridge. We brought these animals into the laboratory so we could watch them all summer. We watched them reproduce multiple times. We put a couple of males in the tanks. One wasn't good enough, you had to have a couple. And we were then able to, at the end of the summer, age how old these animals were. So those females that had eggs in April tended to be about 3 years old. That was significantly older than the animals on the reef that didn't have eggs. And the ones under the bridges at Channel 5 also were about the same age as these reef later. We call these reef later because we held them in the laboratory for 6 months, and at some time during that 6 months, they actually did have another clutch of eggs. So basically all of the animals we collected from the reef ended up having eggs. The older ones had the eggs early, and that's this graph here. So those ones with eggs early started in April, and again, were basically done very early in the season. Our reef later ones were reproducing much later in the year, June and July, and the handful of animals at the Bay Bridge were really reproducing at the same time as our other reef animals. So older animals at the reef reproduced earlier in the year again. Something else they did was our oldest animals are the ones that had multiple clutches. Lobsters don't just have one clutch of eggs. Older lobsters have, we think, up to 3. In the laboratory, we've seen 4. But again, just because I've seen it in the lab, it doesn't mean it's happening in nature. So our oldest lobsters, many more clutches, up to 3 clutches of eggs, and they're doing it earlier. Older lobsters know how to reproduce. They're reproducing more eggs at the appropriate time of the year. Our Bay Bridge animals, most of them did not reproduce, and some of our other animals from the reef reproduced also. But the biggest difference here was only the oldest animals had multiple clutches of eggs. Wrapping it up, female lobsters in the Western Sambos were much older, more likely to be mature, and they're producing more clutches of eggs earlier in the year. So Western sandwich lobsters are bigger because they're older, growing at the same rate as lobster in the fishery. Tortugas lobsters are bigger because likely they've migrated out there. Maybe the fast-growing animals are the ones that made it out there. We think there's very few animals in the dry Tortugas that actually grew up there. There's not that much juvenile habitat. There is some, but we think the fast-growing animals are the ones that made it to the Tortugas. Lobsters in the open fishing area were much younger, less likely to be mature, likely to produce only one clutch, and that clutch will have fewer eggs. And those eggs are produced later in the year. So at all four measures of reproduction, how many clutches, how many eggs, the timing of it, everything going on in the fishery is slightly less efficient than it should have been in other areas. If fishing for lobsters in other areas of the Caribbean has a similar effect on egg production, the consequences of fishing on the reproductive is likely a concern. That's something that's come up in several different talks today. Has fishing increased in areas like Nicaragua? And it's not just less lobsters. If we knock down the population, there could still be a lot of lobsters there, but there's probably significant consequences to the reproduction of those just because we're changing that age structure, size structure of the population. Wrapping up, awful lot of people that have helped with this. Some of the fishermen that have provided samples for age were Gary, Ernie, and Pete Worthington. Somebody I didn't mention was Carrie's Mage professor when she was getting a degree, Charles Gerby out of Georgia State University. Certainly his abilities in the laboratory. He loves lobsters. Totally different reason we do. He's looking at their nerve cells and their chemical abilities. So his approach to looking at a lobster is so different than ours. It's just, it's striking to work with somebody like that who appreciates lobsters for their ability to sense the environment and really just their neurological characteristics and nothing else. And that wraps it up.